Hello, and welcome back to Whip Around Wednesdays, where we showcase the innovation and current events coming from around the concrete world. This week, Holcim has just finished 3D printing 10 affordable houses in Kenya, making it the largest 3D printed affordable housing project to date. The Mavule Gardens Affordable Housing Complex is part of the Green Heart of Kenya regenerative ecosystem, a model for inclusive and climate resilient cities. 3D concrete printing is one of the innovative and sustainable ways in which we are progressing in the world of concrete. This project enables the construction of the walls of a 2-bedroom house in just 18 hours. It's a follow-on from the project 14 Trees World First 3D Printed School in Malawi, cementing this innovative technology as an increasingly viable construction option. The world needs to build 96,000 new affordable homes every day to house the estimated 3 billion people who will need access to adequate housing by 2030, and 3D printing enables fast, resource-efficient, and cost-effective construction. You may already know that cement production accounts for 8% of global CO2 emissions, largely due in part to the selective amount of carbon-free alternatives for the raw materials necessary to create concrete. To help reduce emissions and simultaneously produce enough cement to meet global demand, we look to the use of low-carbon technologies like carbon dioxide capture, utilization, and storage, or CCUS. This technology, while still in its early stages, has the capacity to harness the emissions from cement manufacturing and is already being tested. Mitsubishi Heavy Industries Engineering has agreed to conduct a demonstration testing program at an existing cement plant with the Tokuyama Corporation. The CO2 capture test unit, roughly equivalent in size to two 20-foot shipping containers stacked on top of one another, will harness CO2 emissions from the planet's flue gases, storing them or injecting them into concrete as a raw material. This creates the world's first carbon-negative concrete. Called CO2 SUICOM, it is capable of absorbing CO2 into the curing process. Low-cost and innovative solutions like these help us in creating circular economies and sustainable futures. Australia is also committed to the sustainable future, with low-carbon content concrete sleepers replacing existing wooden sleepers across the Victorian railroads ahead of major construction. The LCC sleepers, developed by AUSTRAK and Cement Australia, reportedly have a 25 to 30% lower carbon footprint than standard concrete sleepers. This is just scratching the surface of the work Australia is doing, with SmartCrete alone participating in numerous projects committed to sustainability and recycled or low-carbon concrete alternatives. Finally, Sydney Build Expo is fast approaching, with opportunities for networking, conferences, and a series of panels centered around diversity in construction. Free tickets are available now. Thank you for tuning in to another Whip Around Wednesday, and we'll see you in a fortnight. Cheers.